Hello students, welcome to Physics Classroom. I am Vaibhav, your physics teacher, and this is the day 2 of our Olympiad series preparation, right? Okay. So in the last lecture we have discussed the introduction of scalars and vector quantity. Okay. Then after that we have discussed the analytical addition of vector. Okay. Just I am going through in the shortly. So what is the analytical addition of vector? I am revising in shortly. The first one, if I take the vector A and I am taking the another vector B, like that. So how can we add then? So there is a one vector A, okay, and another vector. This is vector B, okay. So what should be the resultant vector? It will start from here to here. This is the tail of a vector A and this is the head of a vector B. Okay. So this is the analytical vector, resultant vector, vector A plus vector B. Okay. And I have given the one short formula. This is the magnitude of vector B. It should be A square plus B square plus 2AB cos theta. Alright. And what is the direction of vector C, okay, or the resultant vector? It will be phi, okay, and it will be phi is equal to tan inverse, okay, then it will be B sin theta divided by A plus B cos theta. And what is theta? So theta is the angle between A and B. All right. Okay. So what is the angle? This is the first point. The angle. The second is angle between both vector. So how can we measure the angle between the both vector? So it is the simple thing, means we have to attach this both vector A, the tail of both vector. This is vector A and this is the vector B. We can move just like that, okay, parallelly. So this angle between both vector is theta. All right, this is the theta we are taken here, okay. And what is the phi? Phi is the resultant vector, okay. So the direction of resultant vector, it should be here, okay. See, so this is the phi. So how can we define or how can we represent? This is the phi is the angle of resultant vector from vector A, okay. The phi is the angle of resultant vector from vector A, okay. Then so this is the analytical addition of vectors, right? There is a different types of laws of vectors also there, so we can easily find the direction of resultant vector just like that. So we have three types of laws of vectors, okay, addition of laws of vector. The first one is triangle law, right? Then second one is parallelogram vector, from law of vector addition, okay. And the third one is polygon law of vector addition, okay. So these three we will discuss briefly, okay, in a today's lecture, okay. So what is the first law of addition of vector? Okay, this is the first law of vector addition is triangle law. Law of vector addition. All right. So how can we write just like that? Means here, if I take the vector A, right, and the another vector is vector B, or we can take here also, just like that. This is the vector B. So what is the main point we have to remember to find the resultant vector with the help of a triangle law of vector addition? We have to make a triangle, right? And how can we make the triangle? The first point, remember always, okay, this is the head, right, and this is the tail. We have to add, okay, or we have to join the tail of the one vector to the head of another vector. All right, you can move this A vector here also, all right, or you can move this B vector here also. So here the tail of vector A is attaching to the head of vector B, right, or the tail of vector B we can add or we can attach to the vector head of vector A. Okay, if I am moving, this is the vector B. All right. So what should be the resultant vector? Resultant vector, it will start from the tail of vector, first vector, to the head of last vector. Okay, means here we can take easily, okay, this is the resultant vector. Okay, the addition means this one, addition of A plus addition of vector B. Okay, so the C vector will be the addition of A vector plus B vector. Okay, so here we can easily make one triangle. A vector B, and vector C is the resultant vector. This is the resultant vector, right? So what is the statement of a triangle law of vector addition then? Okay, so we have to add tail of vector, tail of one vector to head of another vector, then the resultant vector it will start from tail of first vector to head of last vector. Okay, this is the statement. All right, this is the first law. The second law, you remember, right? The second law is the parallelogram law of vector addition. The second is parallelogram law of vector addition. All right. So how can we add the both vectors to vectors with the parallelogram? So this is the meaning, right? So we have to make a parallelogram with the both vectors. Okay, the vector means there is a magnitude and a specific direction. Okay, if you are not changing the direction of a vector, okay, so you can move this vector with a specific magnitude in a anywhere also, okay, without changing the angle. Okay, you can move anywhere just like that. Here I am moving this vector b, which is parallelly without changing the direction from here, right? Okay, just like that. So here I am taking this is the vector a, and I am taking the another vector is vector b. So how can we make these one parallelogram with the both vectors, right? Okay, so I am taking this vector, okay, I am attaching the tail of both vector now. Okay, here I am attaching the head and tail of another vectors. Okay, so here I am attaching the tail of both vectors, just like that. Right, now, right, okay, what is the parallelogram? Both sides are equal and parallel to each other. This is the simple property of parallelogram, right? So how can you do that? So here I am making the another one line which is parallel to vector a, okay, is from the head of vector b, just like that. Okay, and I'm making the another one line which is parallel to vector b from the head of vector a. Okay, now we have the one complete parallelogram. All right, just like that. Okay, now the resultant vector, it will start from the, okay, resultant vector will be the diagonal of this parallelogram, okay, and it will start from the combined tail of both vector. Okay, the resultant vector is, it will the diagonal of the parallelogram, and it will start from combined, okay, combined tail of both vectors. So how can we draw that? See, it will be like that. This is the resultant vector C. Okay, means A vector plus B vector and the C vector is our resultant vector. It's like that. Okay, so this is the parallelogram vector addition. Okay, what is the statement then? The statement should be, we have to attach tail of both vector and make a parallelogram by drawing parallel lines to both vector, and the resultant vector is the diagonal of a parallelogram starts from combined tail of both vector, right? This is the statement, right? So here again the triangle law means we have to make one triangle just like that, and the resultant vector, it will start from tail of a first vector and it will end to the head of another vector. And here the parallelogram, so we have to attach the tail of both vector, and so we have to make one parallelogram, and the resultant vector, it will start, it should be the diagonal of a parallelogram, and it will start from the combined tail of both vector. Okay, see here, these are the two laws. All right, now we will discuss about the third law of vector addition. This is also the very easy law. So what is the third law of vector addition? The third law is polygon law of vector addition. With the name of the polygon also you only guess. So there will be the multiple sides. Okay, the diagram we have to follow. Okay, the multiple sides means multiple vectors we have to follow, right? Okay, see here, I am taking the three vectors now. This is the vector A, all right, then vector B, and the another vector is vector C, just like that. Okay, so how can we add these all vectors? It's like that, the vector resultant vector, it should be vector A plus vector B plus vector C. So how can we add this vector? So we have to make, first of all we have to make one polygon. How can that? This is the vector A. Okay, now we have to follow the triangle law only. Triangle law means the tail of one vector attaching the head of another vector. So here I am again following the same thing. I am keeping the direction of a vector is same. Okay, and again the tail of third vector attaching the head of second vector. Okay, just like that. Means here this is the vector. See, all right, that. Okay, now the resultant vector, okay, the resultant vector again it will start from the tail of first vector and it will end to the head of last vector. So how it will be? It's like that. Okay, but how can we calculate? Because we have the analytical formula of a resultant vector, right, to find the magnitude. Okay, so how can we calculate? So first of all we can calculate with A and B. Okay, for example I am calculating the resultant vector, okay, or the 5 plus 4 plus 3, for example. Can I do that? 5 plus 4 is 9 plus 3. Then after that I am adding the 9 with 3. Okay, 9 plus 3 in then 12, just like that. Okay, just similarly, so first of all I am adding the A and B and I am finding the resultant vector R. Just like that. Okay, this is the resultant vector A plus B. All right. Then again I am following, this is a vector 1, resultant vector 1. Okay, again I am following the triangle law of addition with the C. So then it will be the resultant vector A plus B plus C, just like that. Okay, in this way we can calculate the resultant vector for the multiple vectors also. Okay, so what is the statement? Statement is similarly, okay, we have to follow the triangle law of addition. Okay, means add or attach tail of one vector to head of another vector, just like that. Okay, and this process going on till last vector, like that. Okay, and the resultant vector will start from tail of first vector to head of last vector, just like that. Okay, this is the statement. Okay, so these are the three laws to add the vectors. Okay, okay. See. Now we will discuss some questions. So I'm taking one question like the man walked 10 kilometers in east and then 10 kilometers in 60-degree north east. Right. So calculate the direction and magnitude of resultant vector. Okay, this is a simple question, right? The man walks 10 kilometers in east and then 10 kilometers in 60-degree northeast. Calculate direction and magnitude of resultant vector. Okay, so how can we calculate? First of all, the man walks in east. See, this is the direction, right? East, west, north, and south. Okay, the maze in the east direction, man walks 10 kilometers. Okay, and in 10 kilometers in northeast. Northeast means this direction with 60 degree, just like that. This is the northeast. Okay, mean man moves 10 kilometers in northeast direction with 60 degree. All right. So what should be the resultant vector? Okay, the resultant vector is just like that. Okay, this is the resultant vector. Okay, this is the magnitude of vector 1. This is the magnitude of vector 2. All right. So we have one formula. Okay, the calculate the magnitude of vector. Okay, just like that. If I am taking the vector c, the magnitude of vector c, it should be a square plus b square plus 2ab cos theta. Okay, so this is the vector a I am taking, this is the vector b. All right, so now we can calculate. A square is 10 square plus 10 square plus 2 into 10 into 10 into cos 60. Right, just like that. Now, so how can we calculate? Okay, this is the 100 plus 100 means 200. Okay, then plus is the 100 multiplied, this is the 200. Okay, multiply cos 60 is 1 by 2. This will be 100 means total 300 is there. Okay, so what is the value of resultant vector, magnitude of resultant vector? It will be 100 multiply 3 means, can I write 10 root 3 kilometer, right? Okay, this is the resultant vector, magnitude of resultant vector. Right, so we have done this part. The second part is the we have to calculate the direction of resultant vector here. Okay, we have to calculate angle phi also. Okay, so we have the formula is tan inverse b sin theta divided by a plus b cos theta. Right, means here you can calculate the tan inverse b sin theta means 10 multiply 1 by root 3. Okay, sin theta is the sin 60 here. This is also the 60. I am putting 60 degree here. Here also 60 degree. Okay, 1 by root 3. Just a second. So how can we calculate? See, you have to remember two formulas. Okay, this is 30, 61, right? Then root 2. Sorry, this is 2. Okay, and this is root 3. So here this will be root 3 by 2. All right, then b means 10 plus b cos theta means 10 multiply 1 by 2. All right, this is 5. All right, this is 5. Okay, just like that. So this will be 5 root 3, or we can calculate the tan inverse 5 root 3 divided by 15. Okay, 15 means 1 and 3. Okay, so again here it will be root 3. So tan inverse root 3. So this is the value of angle phi tan inverse 1 by root 3. Okay, so how can we find? So there is a one easy short trick is there. Okay, so if I remember, there is a one simple form we will discuss in the upcoming classes. Okay, what is the trigonometric ratios and all. This is 30 degree, this is 60 degree, this is 90 degree. We have to write 1 here, we have to write 3. Okay, and so here is 2. All right, the tan means opposite upon adjacent. Okay, there is one opposite 1 is there, and adjacent is the root 3 is there. Okay, means the root 3 will become adjacent for which angle? 30 degree. 1 is opposite to which angle? Okay, 30 degree. Means our the phi value will be 30 degree. Okay, this is the angle of resultant vector. This is the angle and this is the magnitude. Right. Just like that, we can find the direction and the magnitude of resultant vector. Okay. Now we will discuss. I am erasing this. Subtraction. Okay. First of all, we have discussed the additions, right? Okay. What is subtraction? Subtraction of vectors. Okay. The subtraction is nothing but the addition of one positive vector and one negative vector only. Okay, just like that. Okay, the vector C is the addition of A vector plus B vector. This is nothing but a addition. All right, so here I am taking is the vector A. Okay, and there is another vector is B. Okay, but what is negative vector? Negative vector. The negative vector means the magnitude remains same but direction get reversed. Okay, the direction of a magnitude will get reversed. If this is the vector B, so what should be the minus of vector B? It will be just like that, in the opposite direction with a same magnitude. Okay, now we can add this is the vector A and minus of vector B. Okay, means the resultant vector, it is addition of vector A plus minus of vector B. Now if you are removing this bracket, so it will become vector A minus of vector B. This is the subtraction of both vectors. Okay, this is the subtraction of vector. Okay, so how can we calculate then, and how can we calculate or how can we find the direction of the resultant vector here then? Okay, again we have to follow the same laws. You can follow triangle law also, you can follow parallelograms also, right? Okay, so here I am moving this vector. Okay, so I am attaching the tail of this vector to the head of this vector, just like that. Okay, so I am following the triangle law of addition here. So the resultant vector will be there. It will be start from tail of a vector 1 to the head of vector second, just like that. And this is the resultant vector, or the C of vector, it will be the resultant vector, just like that. Okay, similarly, okay, so how can we calculate the direction of resultant vector also? Okay, you can easily calculate. This is the both vectors are there, no? Right. This is the angle between the both vectors will be there, just like that. Okay, you can calculate there also. Means you can easily calculate the subtraction of vectors with the find laws of vector addition only. Thus we have to get reverse the direction of the second vector, means it will become negative. This is the negative vector. Alright, the negative vector is nothing but the magnitude will should be remain same and direction get reversed. Okay, so that's all for the today's day. Okay, in the next day we will discuss about the different kinds of vector, different types of vector. There are the different types of vectors, that's the unit vectors, right? Then displacement vector, position vectors we will discuss in detail. Then we will go in the next chapter, it will be the trigonometric ratios. Why? Because the such type of small concepts, these are the very important concepts to understand the physics. Okay, you are all are studying in the 8th standard, 9th standard, 10th standard, right? Okay, for preparing the physics olympiad. Okay, but in the school syllabus, so these small concepts are not there, right? Okay, so that's why we have to discuss such type of concepts. Then we will go the small basic concepts, all are the maths topic, right? Okay, but you all know the maths and the physics all are both are brothers or sisters, you can say, right? And they cannot live without each other. Means we cannot understand the physics without the maths. Okay, so we will discuss the small quantities, small concepts are there. Okay, these are the very important concepts. Okay, then we will go for the main topics, just like the kinematics, dynamics, work and energy, right? Okay, in details. But without this concept it is not possible. So that's why make practice of such type of questions. I will give the some list of questions to practice in your home also. Okay, in the description box I will upload some amount of questions. Okay, you will get a Google Drive links. Okay, so I will upload some PDFs. Okay, you can make the practice in your home with you. Okay, if you are not understanding such type of questions, or if you are any doubts, okay, so you can ping me or you can give the comment, okay, in the video. Okay, so we will discuss the such type of questions in the next class. Okay, so till then stay tuned.